We all use AI every single day, but have you ever stopped to think about what it actually takes to build a massive, frontier-level AI model from scratch? I'm talking about the giants, the models that cost hundreds of millions of dollars just to switch on. Today, we're breaking down the exact step-by-step engineering blueprint of how these digital brains are created. Let's get into it. Step 1 is all about the data. Before an AI can think, it has to read. And I don't mean reading a few books, I mean reading essentially the entire public internet. Engineers write massive web scrapers to download petabytes of raw text, Wikipedia, Reddit, scientific papers, and vast code repositories. But the internet is full of garbage, so the first real engineering challenge is building massive data pipelines to filter out duplicate content, fix broken formatting, and strip away low-quality text. You're left with the corpus, the clean, concentrated knowledge of humanity. Step 2 is coding the brain. You don't just install an AI, you have to write the mathematical framework that allows it to learn. This is where hardcore software development comes in. Using languages like Python and C, engineers build a transformer architecture. They write the scripts that define how the neural network's layers connect and how it breaks down human language into numbers called tokens. They rely heavily on frameworks like PyTorch and use systems like CUDA to ensure the code can talk directly to the hardware for maximum acceleration. Now we hit step 3. Pre-training. This is the brute force phase, and it is where the illusion of a single developer in a basement disappears. To train a model of this magnitude, you need a custom-built data center. We're talking tens of thousands of enterprise-grade GPUs, all linked together with high-speed fiber optics. You feed your massive, clean data set through the Python architecture you built. The model guesses the next word, checks if it was right, and adjusts its internal math. Doing this trillions of times takes massive server farms running 24 hours a day for months. The electricity bill alone is staggering. Finally, step 4, alignment and fine-tuning. After months of supercomputing, the AI is incredibly smart, but it's basically just a wild autocomplete engine. It doesn't know how to have a conversation yet. So, engineers use RLHF, reinforcement learning from human feedback. Thousands of humans test the model, have conversations with it, and grade its answers. They penalize it for making things up and reward it for being helpful and safe. This fine-tuning is what turns a massive mathematical calculator into the professional assistant you chat with today. Building a frontier model is no longer just a coding challenge, it's an industrial undertaking. But the software architecture underneath it all, that is something you can start learning on your own machine today. If you found this breakdown helpful, drop a like, hit subscribe, and let me know in the comments what IT topic we should decode next. See you in the next one.